In this video, I want to quickly discuss Jeff Bezos' recent flight on the Blue Origin New Shepard rocket, and why saying that he went to space is technically correct by all means, but kind of gets the wrong idea across, in my opinion. Now, before I begin, I just want to say that while I do think this whole thing was pretty much a marketing exercise for Jeff Bezos, I totally respect the engineering effort put in by Blue Origin's engineers, since making a rocket that can carry humans anywhere is hugely impressive. So kudos to them, at least. Now, the basic problem is that if this is Earth, and say this is the atmosphere, we normally think of space as everything else. You know, the ISS is up here orbiting around the Earth. The moon's somewhere 50 feet that way. You get the idea. The basic problem is that Jeff Bezos, the flight path that Jeff Bezos was on was basically just that. He just barely crossed the border of the atmosphere, which is defined in most cases as 100 kilometers or about 62 miles. And the definition is basically just based off of where orbital mechanics becomes more important than aerodynamics to the flight path of something. So Jeff Bezos and the other 3 passengers just barely crossed that line. And so you're thinking, well, that's space. And yes, it is. The problem is that in order to cross this line, if you're just going, fix that hole. If you're just going straight up like this, just going over into space a little bit and then falling back down, you need to go from the surface of Earth about 1,450 meters per second, which sounds very fast, but the problem is that in order to getting to space is relatively easy. 1,450 meters per second might not sound that easy, but compared to staying in space, it's a walk in the park. Because in order to stay in space, you need to get up here somewhere, and you can, most efficient path is about that there. And that takes around 1,600, 1,450 meters per second to get there, just depending on atmospheric drag, really, and the path you take. But then from this point here, a little rocket would need to go 8 kilometers per second sideways in order to stay in space to orbit around. And the reason for this is that that's the speed you need to go at, such that basically your momentum makes you go sideways quickly enough that you're basically falling to the same elevation because of the curvature of Earth. Basically, gravity is sort of, you want to fly off outwards because of centrifugal force, and gravity is pulling you back down, and those two forces cancel each other out. So getting to space takes about 1,600 meters per second. Staying there takes about 9,400 meters per second of acceleration. And in orbital mechanics, this is referred to as delta V, which is drawn like that, or change in velocity. So Jeff Bezos did get to space, by all means, but getting to space is easy. The X-15 plane, which was a relatively small rocket-powered vehicle, could get to space, and it did 3 or 4 times. It crossed that 100-kilometer border. But staying in space is vastly more difficult. And it's not even just, this number is 4 or 5 times this number. Because if you want to get to space, you need to bring more fuel with you. But in order to get that fuel to space, you need more fuel to get that fuel up. So for every 1,000 meters per second you want to add to your velocity, or delta V, you need to multiply the mass of your rocket by about 1.5. So this is about plus 8,000 meters per second. So 1.5 times 1.5 times 1.5 times 1.5 for every kilometer per second. 1.5 to the power of 8 is 26. It takes 26 times more fuel to stay in space than it does to get to space. And that's sort of the fundamental problem with saying Jeff Bezos went to space. Yes, he did, but getting to space and staying in space are two entirely different things. Because, for example, SpaceX, their Falcon 9 rocket went to space. The first one managed to get above this imaginary line we have at 100 kilometers. It got above that line in 2010. It took over 2 years for them to develop the rocket far enough that it could actually stay in space, to achieve orbit. So getting to space and staying in space are quite different things in level of difficulty. Now, a quick history lesson in the difference in getting to space and staying in space. In 1961, the Soviet cosmonaut Yuri Gagarin became the first person to ever go 100 kilometers, or about 62 miles, above the surface of the Earth. He also, in that exact same flight, was the first person to ever orbit the Earth. And it was actually extremely impressive that the Soviets were able to do both of those things first in the same flight. That was quite the achievement. The Americans got their first person in space a month later in 1961. His name was Alan Shepard, which is where the name of Blue Origin's New Shepard rocket comes from. And unlike Yuri Gagarin a month before him, he only went to space. He didn't stay there. If this is Earth, he only went that. Yuri Gagarin did that pretty much, and then came back down about 1 1/4 orbits later. Alan Shepard only went into space briefly. He didn't orbit. He basically did what Jeff Bezos just did. It wasn't until nearly a year later that John Glenn was the first American to orbit the Earth. John Glenn is where the name of Blue Origin's New Glenn rocket comes from, which is their sort of future rocket that hasn't been fully developed yet. So it took a year of extreme technological development for NASA to go from sending someone to space to sending someone in space and having them stay there for an orbit. That's how different those two things are. So that's my problem with saying that Jeff Bezos went to space. It is technically correct. He did go above the atmosphere. I just think that it gets the wrong idea across to anybody who doesn't know that much about orbital mechanics or how rockets work. And I hope that if you are one of those people, that you learned something interesting and informative in this video. So thank you for watching. Have a nice day.